right, working on number 33 for the geometry final review worksheet. We start with this figure. I've highlighted all of the measurements that we need to find. Those are listed right down here. They tell us that BG is perpendicular to AC. So that means that, I'm going to change colors. That means that I have a right angle here and here. And it tells us that D and F are midpoints. So if this piece is 10, this piece is 10. So that gives me this triangle right here, BGC. And we know the hypotenuse is 20, and we know the leg is 16. I recognize this as a Pythagorean triple. This is 16 is 4 times 4. 20 is 4 times 5. So that means I've got a 3, 4, 5 triangle. All of them have just been multiplied by 4. 3, 4, 5 triangle. Now, of course, you can solve this one by using the Pythagorean theorem. We could say a squared plus 16 squared equals 20 squared, and solve this, but you'll find out that it is 12. So BG is 12. This whole thing is 12. Now, since D and F are midpoints, and these two lines right here are parallel, that means I could also draw a third line parallel to those two down here that passes through G, and that would give me the theorem that I could use about parallel lines being cut by a transversal, that they're all going to be proportional. So this is a ratio of 1 to 1, 1 to 1, 1 to 1. So what that's telling me is that each one of these pieces right here is 6. So BEG is 6. Okay, now I have a right triangle right here that looks like it's going to be a 6, 8, 10 right triangle. So I've just found EF is 8. Here's another right triangle right here. So that means this is also going to be a 6, 8, 10 Pythagorean triple. So BF is 10. And let's see, over here I have this big right triangle, ABG. And this is 9, and this is 12. That looks like it's going to be another Pythagorean triple. This is 3 times 4. This is 3 times 3. So this looks like it's going to be a 3, 4, 5. So this will be 3 times 5. So this side length right here, AG, is going to be 15. And then we still need to find BD. Okay, so remember this one right here is a midpoint. So I know that the whole thing is 15. So this is 15 over 2. Oh, let's see what else I know. I have I found this one a while ago. Let me go back and look at my notes. No, I didn't find that one. So this one right here, I have this 9 and 15. I know those two sides, but I don't know that it's a right triangle. I'm not sure what I'm going to do to find that one, so we may have to cheat and go back and look and see what it is, because I don't see right off the top of my head. Of course, it could be because there's so much stuff going on right here. I I don't know anything about the angle measures. I know this is a right triangle. I don't know that this is a midpoint. So this is 12.5. That doesn't tell me anything about this one. I don't think this one is parallel to anything. So I'm not sure. Let's go see what the answer is. I found all of them but BD. So let's go check out the answer. This is number 33. And they say BD is 15/2 as well. That's what I thought I remembered. But let's see. We can go back and figure out why are these two the same. They're saying that these two are the same. Do I know anything about the angles? So these two right here are equal, and I don't know why. Why is that an isosceles triangle? This is a 6, 8, 10. I know that these two pieces are equal. These two, that's the midpoint. I don't know why that one is. But anyway, that's the answer to that one. So it's just something that I'm missing, and I don't want to waste your time coming up with it. I'm sure that there is something very obvious right here that lets me know why these two side links right here are the same size. I'm just missing it. So we're going to move on to the next one because it is quite a doozy itself. I don't think this next one's really that fair to you because it involves something that you don't even know yet, and you'll learn it in a trig class. But it's this piece of information is what one of the things that is going to allow this problem to work. So I'm going to go ahead and get started. These are the ratios that they want, the area of triangle 1 compared to the area of triangle number 2. And these are all based on similar triangles. I can prove that triangle AEB, and yes, I flipped it around, AEB, that's this one right here. This is triangle number 2. I can show triangle number 2. Let me get my purple pen. So this is triangle number 2, and this is triangle number 4. Okay, I rewrote them so that their corresponding parts were arranged. So this is vertical angles. So angle E is vertical with this other angle E. I also renumbered them so it'd be less work for me whenever I start explaining what the answers are. These are alternate interior angles. So by angle similarity, I know that those two triangles are congruent. So by angle similarity, I know that triangle AEB is similar to triangle CED. Okay, and so since I have corresponding sides, the side mark 7 and the side mark 11, since I have those corresponding sides, I know the scale factor that I can use to find all the other sides can be 7/11, or I could use 11/7, either one. So the trick here is to call this side X and this side Y, or vice versa. It doesn't matter. X and Y are just the variables that I picked. You could use any variables, X and Y. But using proportions now, proportional sides, I picked AB over CD, so 7/11. And then I picked AE, this side right here. And AE is going to be over X. That's the corresponding side. So if you write that proportion down and you cross multiply, you find out that AE here is equal to 7/11 times X. So I'm going to go over here and fill that in. AE, this side right here, is 7/11 over X. Okay, that's the length of that side. 7/11 times x. And then we do the same thing right here. We do 7/11. Those are corresponding parts. And BE is corresponding to ED. So BE over Y, cross multiply. And you find out that BE is equal to 7/11 times Y. So EB right here, this is 7/11 times Y. So I have all of these sides right here labeled, and the reason that all of these sides are important is because I'm going to use this formula right here to find the area of each one of these triangles. Now, by the way, I've already got the answer to question number 3. Question number 3, they want the area, since I've proved that these two are similar and I have the scale factors, then the scale factor is 7/11. That's the scale factor for 2 and 4. Then you take the scale factor and you square it, and you get 49/121. That's the scale factor of the areas. Okay, so I've got the answer to that one, 2 and 4. So now, in order to find the scale factor for the areas of 1 and 2, I'm going to have to use this formula right here. I'm going to do 1/2. And for triangle number 1, one of the sides is labeled Y. So AB, this is 7/11 times X times the sine of angle 1. Okay, and then on bottom, that's for triangle number 1. For triangle number 2, it's 1/2. One of the sides is 7/11 times X. The other side is 7/11 times Y, and that's times the sine of angle 2. Now, here's the part that if you don't know, and if you don't know this, then this doesn't help you very much at all. But in trig, you'll learn about these things called identities, and they're equalities that happen that you may not have noticed yet just with your brief introduction. And one of the things that we've learned is if you take the sine of an angle, then the sine of the supplement of that angle, and that's what this is right here, the supplement, the sine of the supplement of the angle will be the same. So in other words, the sine of 60 is the same thing as the sine of 120, because 60 and 120 are supplements. The sine of 100 degrees is the same thing as the sine of 80 degrees. And you can check me out by typing it in the calculator if you want to. But the sines of supplements are equal to each other. Now, angle 1 and angle 2 are supplements. So since those are going to be equal to each other, those are going to divide out. All right, the 1/2s are going to divide out. This y is going to divide out with that y. This x is going to divide out with that x. The 11 can divide out with that 7/11. And what I'm left with is 1, because everything on top divided out. And I end up with 7/11 on bottom. And so keep, change, flip, and that becomes 11/7. So when I compare the area of triangle 1 to triangle number 2, I get the scale ratio of 11/7. So this one is 11/7. And then for number 2, this is number 1, this is number 2, I compare 1 to 3. So I'm going to do the same thing for this one. For 1 and 3, I'm going to say 1/2. I'm using this area formula, 1/2. The side times the other side times the sine of angle 1. That's the area of triangle number 1. And then the area of triangle number 3 is 1/2 times one side times the other side times the sine of angle 3. Well, what do we know about the sine of angle 1, or angle 1 and angle 3? Those are congruent angles. So the sine of those angles are going to be congruent. So that's going to divide out. The 1/2s are going to divide out. This y is going to divide out with that y. This x is going to divide out with this x. This 7 is going to divide out with that 7/11. What did we just find? The ratio is 1 to 1. The ratio of the areas is 1 to 1. Okay, so now we're going to do this last one, and this last one is going to be, well, we already know that the ratio of areas for triangle number 2 is 49. So for the top part, we know it's 49. And now we've got the ratio 7/11 right here to help us. We take the 7 up here and we square it, and that's where we got the 49. We take the 11 down here and square it. Now, for this four-sided figure right here, this quadrilateral, we've got to, if we add the areas of all three of those, if we add those areas, then we will get the area of that quadrilateral. So the areas of, let me see if I can do this. We'll do shape 1 plus shape 2 plus shape 3 plus shape 4. Okay, so the scale factor for shape 2 was 7. So 7 squared will give us 49. The scale factor for shape 4 down here was 11. So 11 squared will give us 121. And now we found that, remember, the area of 1 to 2 was these ratios right here. Compared 1 to 2, this was 11. Well, this means that 11/7 of this 49, if you do 11/7 times 49, then you're going to get 77. And 11/7, since that's the ratio of this one right here, then for triangle number 1, 77 is the area. And since 1 and 3 were a 1-to-1 ratio, 77 will be the scale factor number that will represent the area to number 3. If you add all of those numbers together, you get 49 over 324. And I am pretty sure that's the answer. 49 over 324. 49 over 121. 1 to 1, 11/7. So I'm going to go ahead and stop the video now. The last question that finishes up is a proof. And I'm not sure what the time is so far on this one, so I'll just put the proof on the last video.